Vimala, Assistant Professor, Department of Computer Science, working in St.Josephs College of Arts and Science for Women, Vasoor. My topic is clipping from the subject Computer Graphics. What is a clipping? The primary use of clipping in computer graphics is to remove objects, lines or line segments that are outside the viewing pan. The viewing transformation is insensitive to the position of point related to the viewing volume, especially those points behind the viewer, and it is necessary to remove these points before generating the view. First clipping is a point clipping. And point clipping in computer graphics refers to the process of determining whether a point lies within the specified region or window, and if it does not, either discarding it or modifying its coordinates to bring it within the valid region. Clipping is an essential step in rendering graphics, as it ensures that only the visible portion of a project are drawn on the screen. The most common application of point clipping is in the context of viewport or window clipping. A viewport is a rectangular area on the screen where the graphics will be displayed. Points outside the region are either discarded or adjusted to fit within the viewport. Point clipping, defining the clipping region, that is a viewport. What is a viewport? Specify the boundaries of the region or window where the graphics will be displayed. The region is often defined by minimum and maximum value of x and y coordinates. You can see in the image, that is, we are representing the window size, that is a square bracket, that is a square. Within that there should be a point. That the square is a viewport, that is a view boundary. Next point, check point visibilities, whether its coordinates fall within the specified clipping region. X handle clipping. If a point is outside the clipping region, you have a few points, that is, discard the point, that means ignore the point and do not render it, or clip the point, modify the coordinates of the point to bring it within the clipping region. This may involve adjusting the x and y coordinates. Two possibilities. One, we want to ignore the point. Otherwise, we want to adjust the point and bring within the clipping region. Another one is the line clipping. Next clipping is line clipping. The concept of line clipping is same as point clipping. In line clipping, we will cut the portion of line which is outside of the window and keep only the portion that is inside the windows. The most popular clipping algorithm method is Cohen-Sutherland line clipping. This algorithm uses clipping window as shown in the following figure. That is, minimum coordinate for the clipping region is xw minimum, mean, and yw mean, and xw mean and yw mean. The maximum coordinate of the clipping region is x max, y max. Image, no, see, this is the image. Here the four among this 1 2 3 4 5 lines, only one line is fully inside, two lines are outside. Among two lines, another two lines are partially inside and partially out. Some among that line, one partial line is inside the boundary and the remaining lines outside the boundary. So here you see the line completely inside the window, the line should be accepted. The line completely outside of the window, not accepted. Line partially inside the window, find the intersection point and draw only the part that lie inside the region. Next, determine by comparing endpoint coordinates to the clip boundaries. Any value 1 in any bit position, the point in that relative position. Then calculate intersection point values completely contained within the window 0, 0, 0, 0 for both endpoints. Next, polygon clipping. Polygon clipping is another clipping. Polygon clipping is a crucial aspect of computer graphics that involves determining the visible portion of the polygon within the specified regions or window. This process ensures that only the part of the polygon that lie within the viewing area are rendered and display and improving the visual representation of computer graphics. There are various algorithms for polygon clipping, but notable is Sutherland-Hodgman clipping. Here is a general explanation of the steps involved in the polygon clipping. We can see they are having the star in the images. In the images, we can see what are the outside of the outside boundary has been removed. Last seen the last figure, only the part that lies within the boundaries has been accepted, others are removed. The C steps in Sutherland-Hodgman algorithm. Sutherland-Hodgman algorithm. Define the clipping region, specify the boundary of the region where the graphics should be displayed, and the clipping window is often defined by minimum and maximum value for x and y coordinates. Then identify the edges of the clipping window. Break down the clipping window into the individual edges. This typically results in 4 edges corresponding to the left, right, top and bottom side of the window. Next, clip against each edge. For each edge of the clipping window, clip the polygon against that edge. This involves examining each edge of the polygon and determining the intersection within the clipping window edge. Update polygon. After clipping against one edge, update the polygon based on the intersection. The updated polygon is then used as the input for the next clipping stage. Repeat for each edge. Repeat the clipping process or for each edge of the clipping window until the entire polygon is clipped and visible within the specified region. Next is the curve clipping. Curve clipping in a computer graphics refers to the process of removing parts of a curve that lie outside the specified region. See in the image we have shown a circle. Among that, part of the curve only inside the boundaries, remaining has been discarded or removed. The purpose of curve clipping is to display only the portion of curve that is visible within the specified area. Next, what is the curve clipping process? Window definition. A viewing window or clipping window is defined. Specify the region of the graphical space in which the curve should be displayed. The window is usually defined by specifying its boundaries, often in terms of minimum and maximum coordinates along the x and y axis. Curve representation is used by mathematical equations or parametric equations. Clipping algorithm. Apply a curve clipping algorithm to determine the portion of the curve that lies within the window. Common algorithm is the Cohen-Sutherland curve algorithm. Discard or display the portion of the curve that fall outside the window based on the result of the clipping algorithm. If the algorithm determines that a segment of the curve lies entirely outside the window, it is discarded. Otherwise, only the visible portion is displayed. Update display. Update the display by rendering or drawing the visible portion of the curve within the specified window. Next, text clipping. Text clipping in computer graphics refer to the process of determining which portion of the text or character should be displayed on the screen or viewport based on the specified boundaries or regions. This is particularly important when rendering text in a limited space, such as within a window or designated area or a computer screen. There are 3 methods of text clipping. All are non-string clipping, all are non-character clipping, text clipping. In all are non-string clipping, In all our non-string clipping method, either we keep the entire string or we reject the entire string based on the clipping window. As we seen in the above figure, string 2 is entirely inside the clipping window, so we keep it. String 1 is only partially inside the window, so we reject it. In all our non-character clipping, this clipping method is based on characters rather than the entire string. In this method, if the string is entirely inside the clipping window, we keep it. If it is partially outside the window, then reject only the portion of the string being outside. If the character is on the boundary of the clipping window, then we discard that entire character and keep the rest string. See in the example, string 1, string 2, string 3. So after the clipping, we see string 2 is completely inside, so it is accepted. In string 1, ing1 is inside, so it is accepted. In string 3, or ing3 is inside, so it is accepted. Remaining is discarded. That is all our non-character clipping. Next is the text clipping. In this clipping method is based on characters rather than entire string. In this method, if the string is entirely inside the clipping window, then we keep it. If it is partially outside the window, then you reject only the portion of the string being outside. If the character is on the boundary of the clipping window, then we discard only that portion of the character that is outside of the clipping window. See the same image. The string 2 is completely inside, so it is accepted. In the string 1, ing1 is completely inside, so it is accepted. At the same time, in the string or is kept on the left on the boundary. So even though it is left on the boundary, that is also accepted. See in the string 3, or ing is inside the boundary, so it is accepted. Of the t of the partial, that is right hand of the upper t, is inside the boundary and lie on the boundary, so it is also accepted. This is the text clipping. Thank you.